The increasing use of lightweight materials, such as die-cast aluminum, magnesium, and high-strength steel, has led industries to re-examine traditional methods of assembly. Welding these materials is difficult and often not possible, while assembling with conventional rivets and adhesive bonding can be slow and costly. As lightweighting in automotive and other industries accelerate, traditional SPR faces three critical challenges: material brittleness and cracking, corrosion, risk, and tooling wear. Originating from AKH Heron Tech's FSPR technology, redefines joining logic. The flush self-pierce riveting process reduces rivet-to-edge distance by 40% compared to conventional SPR methods, saving material and ejecting waste while creating a flush, reliable joint. FSPR successfully joins 9.1 mm three-layer stacks, achieving maximum strength up to 1800 MPa and zero localized fractures during its impact embedding riveting process. While the industry faces limited options for joining high-strength materials in lightweighting strategies, FSPR masters strong, dissimilar, and ultra-low ductility alloy with a high degree of reliability. From carbon fiber aluminum hybrids to magnesium stacks, FSPR handles the toughest jobs with consistency and ease. The HT rivet, engineered for resilience, its signature hourglass shape enables superior elongation, color customization, and corrosion resistance. Whether it's a 96-hour salt spray or 480-plus hours of E-coat protection, HT rivets are built to last. From butterfly doors, bumpers, to battery covers, FSPR enables lightweight vehicle designs to come to life. With over 15 verified applications, HT's process ensures strength without compromise. The ZM6 Intelligent Systems automates precision. With fewer die changes, force feedback monitoring, easy magazine, and C-frame switching, production stays smooth without sacrificing quality. With Heron Tech, you can expect global network to support your joining needs, serious commitment to R&D. Partner with Heron for sustainable innovation. Join innovative materials with HT.